For the last 20 years, we have been living under a highly profitable, carefully constructed illusion. We called it the cloud. It was a brilliant piece of marketing. It taught us to imagine our emails, our movies, and our software floating invisibly above us, weightless and ethereal. For a generation, this asset-light era allowed kids in dorm rooms to build billion-dollar empires with nothing but a laptop and a Wi-Fi connection. But as we move through 2026, the artificial intelligence boom has violently reintroduced Silicon Valley to the heavy, unyielding laws of physics. The greatest threat to the artificial intelligence revolution is the American power grid. Right now, the technology industry is caught in a panicked realization. AI is unsustainably power-hungry, facing the very real prospect of rolling blackouts, multi-year connection delays, and stalled software development. The most valuable companies on Earth are executing one of the most drastic strategic pivots in corporate history. They are realizing that whoever controls the electricity controls the future of computing. And so, they are bypassing the public utility grids entirely and going straight for the most powerful, controversial energy source in human history: nuclear fission. This is the story of how big tech triggered a 1,000 terawatt-hour energy crisis, why green energy cannot save them, and the $650 billion race to control the grid. Welcome to the uranium monopoly. To understand why software companies are suddenly in the business of buying nuclear power plants, you have to look at the fundamental difference between the old internet and the AI era. Historically, data centers were essentially massive digital filing cabinets. When you opened a YouTube video or searched Google for a recipe, a server simply retrieved a specific file from a hard drive and sent it to your phone. It was a highly efficient, low-energy retrieval process. But generative AI systems, like OpenAI's ChatGPT or Google's Gemini, do not just retrieve information. They calculate it from scratch. When you prompt a large language model, it doesn't just look up the answer. It forces thousands of high-performance GPUs to calculate the mathematical probability of every single word from scratch, in real time. Because of this brute force mathematical density, generative AI uses roughly 33 times more energy than traditional software. A single ChatGPT query requires nearly 10 times the electricity of a standard Google search. And that is just for the day-to-day answering of your questions. The energy required to actually train these frontier models in the first place is almost incomprehensible, pushing past 100 million kilowatt-hours for a single training run. That is enough electricity to power a small American city for an entire year, consumed by a single building in a matter of months. To house these power-hungry chips, hyperscalers like Microsoft, Alphabet, Amazon, and Meta are executing an unprecedented capital expenditure sprint, projecting to spend nearly $690 billion collectively in 2026 alone. But you cannot just plug a $100 billion data center into a standard wall outlet. By 2030, global data centers are projected to consume upwards of 1,000 terawatt-hours of electricity. That pushes toward 5% of the entire planet's power demand. An energy footprint roughly equivalent to the entire nation of Japan. Silicon Valley has a massive problem. They have infinite money. They have the chips, but they are quite literally draining the grid dry. For the past decade, tech companies poured tens of billions into wind and solar. But the AI boom exposed a fatal flaw. You cannot run a hyperscale data center on the weather. Intermittent renewables cannot provide the 100% uninterrupted power AI demands, and the massive battery arrays required to bridge multi-day gaps would cost tens of billions, bankrupting projects before they even start. AI requires what grid operators call baseload power, heavy, unblinking electricity generation designed to operate continuously without fail. Because of this baseload trap, tech companies have been forced to rely on dirty, fossil fuel-backed grids to fill the gaps. The consequences are embarrassing. The aggressive deployment of AI infrastructure is actively destroying big tech's climate pledges. In 2024, Google admitted its greenhouse gas emissions were nearly 50% higher than in 2019. Microsoft's rose 30%. They needed massive, gigawatt-scale, carbon-free power that never turns off. And right now, there is exactly one technology on planet Earth capable of providing that: nuclear fission. This utter desperation for clean baseload power led to the most symbolic, unthinkable energy deal of the modern era. In late 2024, Microsoft finalized an unprecedented 20-year power purchase agreement with Constellation Energy. The objective? To completely reactivate Unit 1 of the 3 Mile Island nuclear plant in Pennsylvania. For decades, 3 Mile Island occupied a dark place in American history following its 1979 partial meltdown. But its undamaged neighboring reactor, closed in 2019 for purely economic reasons, is now being painstakingly rebuilt. The AI boom radically altered the economic calculus overnight. Constellation Energy is now investing $1.6 billion to rebuild the turbines and cooling systems. Microsoft is so desperate for power that they are buying 100% of the plant's 835 megawatt output for the next 2 decades, enough power for 800,000 homes. It is a monumental financial flex. Microsoft's willingness to underwrite these immense restart costs proves that hyperscalers possess both the infinite capital and the terrifying operational incentive to drag dormant nuclear assets back from the dead. But while Microsoft was simply buying power, Amazon decided to buy the grid itself. Amazon Web Services acquired a 1,200-acre hyperscale data center campus from Talon Energy for $650 million. The immense strategic value of this campus had nothing to do with the buildings on it. It lay entirely in its geography. It is located inches away from an active 2,500 megawatt nuclear power plant in Pennsylvania. By positioning the data center exactly adjacent to the active reactor, Amazon executed a brilliant, highly controversial maneuver known as a behind-the-meter arrangement. Connecting a massive data center to the public grid currently requires surviving a multi-year waitlist of environmental reviews and grid upgrades. In the AI race, waiting 5 years to plug in is a death sentence. A behind-the-meter setup is a logistical loophole. The electricity flows directly from the nuclear reactor into Amazon's private server fortress, without ever touching the public transmission wires. By bypassing the multi-year queues entirely, Amazon secured an agreement to siphon off over a gigawatt of carbon-free electricity exclusively for themselves. But Amazon's maneuver triggered an absolute war in the utility sector. Legacy utility giants revolted. Their argument was devastating. The public grid relies on the cheap, stable foundation of baseload nuclear power. If Amazon takes that energy exclusively for itself before it hits the grid, that power goes missing from the public pool. To make up the difference, grid operators have to fire up expensive, dirty, natural gas plants. And everyday citizens foot the bill. In a massive shock to Silicon Valley, federal regulators at FERC handed down a tight 2-to-1 decision, rejecting an expansion of Amazon's grid arrangement. The ruling sent a chilling signal. It underscored a harsh reality. Tech companies may have infinite capital, but they cannot simply buy their way past the regulatory architecture of the United States. Beyond regulation, there is a hard physical limit. There are only so many existing nuclear plants left to tap. Building new nuclear plants from scratch is a logistical nightmare. They are bespoke megaprojects built in muddy fields, notoriously subject to massive cost overruns. Tech companies operate on 18-month hardware cycles. They cannot wait 15 years for power. So, for the long term, Silicon Valley has to shrink the atom. Google and Amazon are now anchoring massive financing rounds to deploy fleets of small modular reactors, SMRs, by 2035. Instead of building custom megaplants, SMRs are designed to be mass-produced in centralized factories. They aren't just buying reactors. They are explicitly funding the fuel fabrication facilities to vertically integrate the atomic supply chain on American soil. By committing billions of dollars to buy fleets of miniature reactors, the technology industry is leveraging its immense corporate balance sheets to underwrite the brutal research and regulatory costs required to finally drag the stagnant nuclear industry into the 21st century. For a generation, we viewed the titans of tech as pure software companies, writing elegant code in glass offices, isolated from the heavy industrial reality of the physical world. the AI revolution has shattered that divide. In the relentless trillion-dollar race to build artificial general intelligence, having the smartest engineers and the fastest microchips is no longer enough. The tech industry has recognized that the ultimate bottleneck of human progress is not algorithmic efficiency, it is electrons. By purchasing the output of resurrected commercial reactors, fighting legal battles to bypass public grid infrastructure, and directly funding the supply chains of next-generation atomic science, corporations like Microsoft, Amazon, and Google are fundamentally evolving. They are no longer strictly search engines, e-commerce stores, or cloud hosting providers. In their desperate search for power, they are rapidly transforming into some of the most powerful, best capitalized utility and energy conglomerates in human history. They are realizing what the industrial barons of the 19th century knew. If you want to command the future, you have to own the power that runs it. They have proven once and for all that the cloud isn't floating weightless in the sky. It is anchored incredibly heavily to the ground. It is bound by the hard, unforgiving limits of the electrical grid. And increasingly, it runs on uranium.